Good afternoon, everyone, and a very warm welcome to this webinar on CBAM, which is the Carbon Border Adjustment Mechanism. This is organized by Bharat Carbon. Thank you all for taking out the time to join us today. We have an insightful session lined up for you. I'm Shela Khan, and I will be the coordinator for today's session.
Thanks a lot, Shaila Khan, for this. Uh, I'm very privileged to be here. Many thanks to Tanish and Bharat Carbon. I will. Can you please share the slides, Shaila?
Yeah.
Before that, I'll just give a brief introduction about myself and CBR. So basically, we are a consulting company based in Germany, based in Hamburg, near to the port. So we are basically the decarbonization experts, technical project developers, or deal advisors, and how to do net zero solutions, basically for all the manufacturing sector. And I myself, I have experience about roughly 2 decades or 20 years of experience in decarbonization. I will briefly walk you through some steps and what basically happens in CBAM with considering from EU importer perspective. And I will walk you so the agenda, probably next slide, Shaila. So the agenda for today's talk is about, I mean, we are not here to talk about CBAM in theory. We are just going to talk about CBAM because it is already hitting your invoice. And this is not a regulatory update because probably you would have known probably from many webinars or many updates on CBAM. So I just want to briefly ask a couple of questions. Probably you can answer in the chat or in Q&A. How many of you already received a request from your compliance team about CBAM data from your Indian suppliers? You can answer that. And also think about how many of you are confident you'll be fully compliant by Jan 2026 or for this year or this quarter. So this is what we are going to address today briefly, and I will walk you through some of what's happening in CBAM and how Bharat Carbon is also handling CBAM from not only from the supplier point of view, also from the importer point of view. Maybe next slide, Shaila. Shaila, can you please go to the next slide? Yes. So before we begin, I just want to walk you through India and EU trade relationship. India is EU's 10th largest trading partner globally and is moving up, and it exceeds above 115 billion euros in terms of revenue. And EU exports 63 billion worth of goods service to India. So what makes this moment particularly significant is that India and EU are actively negotiating a FTA, that is free trade agreement, the first serious attempt in over a decade, because we were eagerly waiting for it, because the last negotiation, it was stalled in 2013 and is again relaunched in 2022. And recently there are many talks between India and EU, especially when it comes to the trade, which means CBAM is not going to be just a custom issue. It is going to become structural feature of India EU trade architecture. So now within 52 billion, whatever India exports to EU, a significant and growing portion falls directly within CBAM scope. Let's look at exactly which sectors are affected and why compliance has become so urgent. So here you see, I just want to categorize the very important sectors. For instance, the most affected sectors to speak about: steel and metal. Obviously, that is going to be one of the biggest sector. And then next comes the chemicals. That's also going to be affected because India has a large export potential in that. Textiles, it is not there yet. It's a good story, but it will soon become a CBAM compliant for sure. That is currently under discussion. Maybe we may have to take into account what's happening in the textile. Engineering, obviously, there are a lot of happening. It's a 9 billion business, and it is not mostly fall under CBAM, but obviously 50% falling in that. Pharma and leather, again, similar to textiles, probably move in the future to CBAM compliant. What I want to say here is, like, the important message over here is tariff reductions could make Indian goods significantly more competitive in EU markets, which means reduction in tariff, we will export more from India. And what happens is when you put CBAM on top of it, then you become the EU importer will check who is becoming cheaper. For instance, if India is sending green steel to EU, then the other players also sending green steel, then it will become very competitive, especially in steel and metal sector. So we have established the scale of relationship and the sectors at risk we know. So why has the compliance urgency intensified sharply in the last, let's say, over 18 months? I would like to walk you through in the next slide. So what's happening is basically you all know that the CBAM started post-COVID. It enters into the transitional phase in October 2023. EU importers of steel, aluminium, cement, fertilizer, hydrogen, and other sectors, they have been reporting. But luckily at that time, there was no certificates, no financial penalty, or it is just mere reporting, right? And after that, a year later, what happened was the data quality bar rose. So the EU importers were expected to use actual verified embedded carbon figures, not defaults where possible. Many found that they couldn't get data from Indian suppliers at this stage. The gap between what was required and what was available started become commercially uncomfortable actually. But Jan 2026 is a kind of a big cliff edge. This is the critical milestone actually. From Jan 2026, EU importers must surrender CBAM certificates. Purchase at the EU ETS carbon price, which is set really high, 80 to 100 euros per ton of whatever the goods is exported or being imported. For every ton of CO2, embedded emissions cover the imports. No exemptions, no more transitional tolerance, and we have to be really compliant from now on. So that is why we are here. We are going to discuss about that part. But looking at the future, 2034 or post 2030, the free allowance will phase out. The meaning is the EU ETS free allowances for EU domestic producers will be fully phased out. This is important because it means that the CBAM price will signal will intensify over time. Today, domestic EU producers still get some free carbon. By 2034, they won't. And neither will importers get any softened exposure at this point. So the carbon cost of imports will be fully priced. So now we know the timeline. Let's look at exactly how CBAM works. For instance, understanding the compliance journey is essential to understand the pressure points for the EU importers, which I will walk you in next few slides. Shaila, can you please go to the next slide? Yes, so I just want to briefly touch on these four points where EU importer face significant challenge. The first thing is obviously that the data collection burden, because the CBAM complaints begin obviously at the production site somewhere in India, somewhere in Pune, Ludhiana, elsewhere. The Indian manufacturer must measure, record direct emissions from the manufacturing process. Let it be burning, let it be blast furnace where they use coal, they have CO2 emissions that has to be, and also they have electricity coming as scope 2. So all they have to put in scope 1 and scope 2 emission standards, right? And this has to be measured and verified and audited. I'll come back to that later. But most Indian MSMEs have never done this till yet, because most of them have export potential. Some of them are actively engaged. Big players, obviously they involved, but most of the MSMEs, they are not yet involved. I'll talk about that later. Many large Indian exporters have only partial systems. This is the root cause of the compliance gap. So here, the data collection burden is obviously there because they haven't set some standardized format or standardized reporting as such. And then the next point is the verification and accreditation gaps. So what we see here from the EU importer point of view is that the embedded carbon data calculated by the manufacturer cannot be simply or self-reported. It must be independently verified by a body accredited by the EU, specifically by a national accreditation body that is a member of the European Council. So this is expensive. MSMEs cannot afford to do that. Big players are doing that, and because this will take away their profit margin or something like that. This is also something we need to EU importer probably face challenges from MSMEs coming the goods crossing the EU border. And the next one is the certificate cost exposure. Obviously, CBAM certificates are purchased at EU registry. It comes at 80 euros per ton or something like that. For steel, the certificate cost even go higher because of the emissions are high. And this has to be also, depending on the carbon intensity and stuff like that. But one good thing probably is one relief mechanism. India is also introducing CCTS, which means that if the Indian exporter has already paid a domestic carbon price, for example, under India's emerging CCTS, that carbon can be deducted. So this is probably some kind of a relief, but it's not huge relief because CCTS price is somewhere around $8 to $10 or €8 to €10 per ton we are speaking about. Okay, so the CBAM obligation sits with the EU importer, not with the Indian exporter. With that, we need to understand clearly. If your supplier in Surat or Pune cannot give you a verified embedded carbon data by now, the importer must either pay CBAM certificates on the default carbon values, which is significantly high, and this will probably put the probably the steel which is coming from India to EU, also put under kind of some kind of a supply chain risk, because this is not just a compliance checkbox. And I will just show in the next slide quickly about the frictions, what exactly we need to do from Indian perspective to satisfy some EU specific frictions. Obviously there is a methodology mismatch, because the EU reporting template is always different when compared to the supplier side, because we have here two sides. One is the supplier side and one is the importer side, and there is the methodology mismatch. And even though it is the same language, they couldn't able to understand most of it because they have a different methodology. So this is one problem. And the second one is verification. Sometimes EU importers couldn't able to verify a specific verification body in India doing that. They have to again do an audit for the audited verification. This is sometimes time consuming, and when they don't understand, they simply put higher CBAM price or higher emission cost. This is problem number two. And problem number three is there is a platform disconnect which we have experienced. So for instance, the EU importer using their own tools, their own AI or ESG tools, and India supplier sites like Bharat Carbon, I mean, use another tool. There is some kind of a registry disconnect or a bridge happening between these 2 points. So this is also significant in the days to come, and probably we have already the solution for this. Let's zoom into the MSME in the next slide for a few minutes, and then I'll conclude my speech. So the implications from MSMEs is MSMEs are kind of a large in terms of, for instance, India is basically steel and aluminum based market, where there are millions of Indian MSMEs. They have a CBAM risk exposure of over 40% because they also have good export for aluminum based the exports. But most of them, unfortunately, their carbon accounting today as of now is zero. I would say it is increasing, but it's still at a very low level, and this year is going to be the compliance deadline. So the next slide, I will take you through specific barriers that MSME face, because understanding the barrier is the first step to design the solution. So here you see most of the MSMEs, over 52%, they are not aware. For instance, they may be domestic players, even they have to also produce the emissions. Probably it's not yet mandatory, but they have to measure, verify, or do MRV or do ESG reporting for this aspect. And some of them are aware, but there are no action. That is over 30%. And some of them are in the basic preparation stage, and some of them, very few, 3%, they are probably coming to the compliance stage. So the meaning is most of them, they have issues in reporting the carbon accounting system. They have awareness gap, and they have to verify, and that is expensive. That eats out the EBIT portion. So they are also having that risk. So they probably, there is a risk of market exclusion for this MSME, which we need to address really quickly. I'll just walk you through some points about the EU accreditors. There are a lot of verification frameworks, and we need to do that in parallel when we do this measurements. For instance, this will be long. There are only 8 accreditation bodies at the moment, and the queue is long. It will take months to get the verified approach. So this is again, there is a lot of pressure, and you are in queue, the supplier side, to verify or audit the data. So they have to be as quick as possible to get the verified carbon data done. I'll just go through one or couple of slides on this part, then I will come to the conclusion. So basically, what I want to say is, like, platform like Bharat Carbon, uh, y- there are a lot of things to do. Obviously, Bharat Carbon doing exceptional job in real-time emission tracking. Of course, you're also involved in pre-verification readiness, accreditor-ready reporting, and also building the MSME first architecture. Obviously, you are looking also the EU imported dashboards. So these are all extremely important in terms of how to bridge this gap between Indian supplier side to the EU importer side. And with that, I will go to my final slide, which is just to conclude or give you a summary. CBAM is no longer optional. And of course, we know that now the Indian supplies need support, just not the pressure. And the verification is a real bottleneck. We have to really plan ahead. Digital platform like Bharat Carbon reduces verification cost, automate data, and generate EU compliant reports. It is a kind of a big, it bridges the compliance gap, and it is probably CBAM, probably a tool to be used as a kind of a competitive advantage. So the question is not whether CBAM will affect your Indian supply chain. It already does. The question is whether you will be ready or reactive for this. So thank you for this. I would be very happy to take questions from Q&A, and I will very happy to address this. Thank you.
Thank you so much, Dr. Prasad. That was a really enlightening session, and we got to know a lot of key points which are still unaware between the people, specifically MSMEs. I would love all of the attendees to please paste their questions on the Q&A section, and we will definitely take that ahead in our last round. Not losing much of time, I will quickly move ahead and hand over to Dr. Rajesh Biniwale, as we spoke of the embedded emissions and exactly the emission parts, and that is where I would like Dr. Rajesh Biniwale to uh, enlighten us on. Over to you, Dr. Rajesh Biniwale.
My slides are visible?
Yes.
Yeah, okay. So, thank you, Dr. Prasad. You have set up a very good tone on the what is that need to look at the CBAM and where is the Indian MSME stands or Indian industry overall stands. Uh, Today my job is to identify what is the background preparation this industry needs to have. Certification is one of the thing which is very important to tell you where you are standing. But once you know that where you are standing, or once you have evaluated even before the certification, what needs to be done, where can be the areas of the improvement, and if that areas of improvement are addressed, what would be the possibility of your product being getting better and better certification in terms of carbon emissions, and if that happens, the MSMEs could survive in all that scenario of large penalties which could be attracting not to the suppliers but at the same time definitely directly impacting to the suppliers. So let me there is a confusion around in the industries, and particularly also some consulting people, that we were lot looking at the carbon credit generation, and then the CBAM is something different. So let me explain this with an example. When a biomass is undergone a pyrolysis or a torrefaction, you get a biochar. And currently, what was thought process was, if that is applicable, this is applied in the agricultural field, so that you can achieve the carbon fixation. These are the eligible for the this is exactly eligible for carbon credit, of course, via certifications like Pure Earth or where such kind of international certifications are important. But no more like in this particular case of application to the agricultural field, uh, including myself and some others, we were saying that it need to prove the fixation of the carbon. Carbon cannot be burned, like biochar cannot be burned and cannot be getting converted back to the CO2. This is very important aspect of the carbon credit. However, the CBAM mechanism is exactly requiring something else. Use of this biochar, which is generated from the biomass, which is a renewable one, used in a boiler as an alternative fuel. to the fossil coal, and that will reduce the carbon footprint or the carbon tag on a particular product. Because currently the Indian scenario, if you look at the coal based thermal power plants, the footprint is uh, zero point 0.9 kg of CO2 per kilowatt hour of the production of the energy. Whereas energy mix, which is recalculated every time and being published, it is if the renewable energies are counted for, it is generally somewhere 0.74. And if you go more and more towards the renewable energy, that is more important. This is one of the way of going to the renewable energy, not the only one. So there is a specific difference between these two mechanisms. Now, what is embedded energy and emissions? Let me tell you. Uh, I look at in the perspective of a mass and energy balance within the system or a premises, which is existing or a planned. And there is a system boundary, which could be, the system boundaries are defined in a different perspective. Many a times it could be cradle to grave analysis, which we follow in life cycle analysis, or it could be get to get analysis also. That means it's a factory gate to the factory in gate to the factory out gate. Now, the question need to be answered here is why MSMEs has to be concerned about this. Uh, I will go to the sectors also, but let me take the example of the steel sector itself. Steel manufacturing is a very big industry, and steel manufacturing is being done at a very large scale. Whereas the MSMEs, which are that too when it's a blast furnace is included or it starts with the iron ore, the steel industry is a very big industry. And when it comes down to recycle steel, there could be some of the small industries which or mid level industries can also get included. More like converging this steel into the different forms, such as the pipes or the mesh, such kind of industries are generally MSME industries. And therefore, the steel sector is getting connected to the MSME industries. So the system boundaries for these MSMEs would be receiving of the steel which is already produced and then formation of this steel into different forms to be used in the structural forms into use. So what happens is you count for the emissions. That's one of the compliance for your factory. But then you start looking at the raw material which is getting into the boundary, system boundary and associated energies and emissions. This is what we started calling it as a what emissions, that's embedded energy or embedded emissions which are getting. Of course, finished product do also carry some associated energy and emissions because your process will add some emissions, and those emissions to be total together, if we accounted for, then it is a finished product will also have some footprint. Generally, the LCA has been used for this purpose traditionally, and it's a good approach to use. Let me tell you, for the steel industry, although the CBAM mechanism is a recent mechanism, my experience of doing LCA for a steel industry in the country was first time was in 1999, year 1999. We did first ever life cycle assessment in the country, and that for the steel industry, and that was required because for the same purpose there were no penalties, there were no as such what do you say mechanisms existing at that time. But Indian steel was not sellable in the market where somewhere Olympics has to happen and the steel was to be sold, and was not being sellable not because of the quality of the steel but because of the 2.5 to 3 tons of CO2 being produced per ton of steel. That was that was the kind of a hurdle which was envisaged at that time, and we did the first time LCA to identify what can be done as a improvement studies for the reduction of this CO2. A few of the sectors which Dr. Prasad has identified, uh, I'm looking at some sectors which are, we call it as a hard to abate sector, and these are the steel and iron, cement, aluminum, fertilizers, electricity, and then comes the hydrogen also, because a lot of emphasizes on the hydrogen production via various mechanisms, and hydrogen surely will find a way, and these are the like mechanisms which we need to find out. Because as I said, steel, and as the example was given here also before, it's a 2.5 tons of almost 2.5 tons of CO2 per ton of steel produced. Whereas aluminium, this figure can go to 7 to 8 tons of CO2 per ton of aluminum produced. and electricity, as already we talked about it. So it's something which is really bothering about these sectors, if at all has to go into the market, and with the CBAM mechanism, it's going to be difficult and difficult. Now, let me give you another example of what embedded energy is. So, embedded energy is, for example, this particular graph is showing the embedded energy with different materials, particularly used in the construction: steel, cement, aluminium, SCC blocks, tiles, everything, and even uh, uh, and most of them, like a steel, cement, and aluminium, they have a huge embedded energy into it. The process energy, the kind of a carbon tag is very high. So this embedded energy we need to look at in a very critical manner. And currently, the mechanism of carbon accounting which we have is identifying the scope 1, scope 2, and scope 3 carbon emissions. Scope 1 is relatively easy, although the certifications would require more and more monitoring and more precise monitoring, and certain points which were not monitored before need to be monitored. But the scope 1 is relatively, I would say, doable for the operation of the equipment, process, everything. Scope 2 is also can be accounted with the different tools which we are having currently, and the transportation materials technologies for waste management, all those comes into the picture. And when you look at how every energy required for anything into the production of that product is has to be calculated. Scope 3 is an indirect for manpower and the value chain, which is there, and which is very, it's a kind of a gray area as of now. What to calculate, how to calculate, where to find the mechanisms to improve upon it. And many reports are currently saying in some percentage of the scope 1 and scope 2 as a scope 3 emissions. Whereas, although the part would remain the, as compared to scope 1 and scope 2, scope 3 will remain the lesser percentage, but we need to really again with this kind of mechanisms where we need to identify what exactly the magnitude of the numbers which are there. I would emphasize over here as one of the things with our Bharat Carbon platform is we have also included the value chain, including even kind of vendor sectors which will come into the demonstrations of the product. But this is an important factor. So scope 1, scope 2, and scope 3 emissions are need to be calculated, and the carbon accounting has to be accurate. Now, there are some challenges. The challenges are typical. One was already said that it is not the self appraiser or the self accounting which is being calculated. So, certification is one. But at the same time, there are few things which need to have a data availability, such as the emission factors. So, if you are burning certain amount of a certain quality of a fuel, what kind of emission factors under which technology conditions? Because it cannot be happening that if I am burning a oil and my burner technology is one and my burner technology is two, and of course the post emissions, post combustion effluents emission control is different technology, it's going to be a different emission factors altogether for that. So calculating the emission factors is also, or getting more and more emission factors is important. One of the point which we have included in carbon accounting is quality assurance and quality control of the data. And uncertainties need to be understood, because there are uncertainties regarding measurement policies and the technologies, other than the mismatch of the platforms or the mismatch of the methodology to be considered. Way forward. What is the way forward then? The way forward is adopt the low carbon technologies, improve the energy efficiency, and shift to the green hydrogen or renewables. Pretty obvious. Anybody can give these 3 points, but then how to do it? That's an important aspect. And let's start doing it like low carbon technologies could be possible, but at the same time, if that is not there, then you need to worry about the carbon capture, utilization, and sequestration. So, carbon capture is having several aspects, one, which are particularly two major categories. One is remediation, and the second is mitigation. So, the post process capture and conversion and the storage can be called as a remediation, where technologies are available and the carbon can be captured, but at the same time, the carbon can has to go to the sequestration. Unless that is happening, your carbon footprint is not going to be lowered in any way. And the mitigation is you increase the energy efficiency, calculate the rather to the level of the quantum efficiencies of the processes, and then find out how the energy efficiencies can be increased, or change the processes, or change the mechanisms of the heat transfer and the material transfer that will happen. Heat recovery has been practiced into the field, particularly in the boilers, but then this needs to be more and more. Even say, for example, we are shifting to hydrogen economy in the mobility sector using fuel cells, and the waste heat recovery there is an important aspect as well. So, and then the raw material characteristics, that is also the mitigation measure. uh, these are the some of the CO2 capture, CO2 utilization, CO2 storage things which perspective if I can put. So CO2 capture, new solvents are coming up. The adsorption materials are coming up. Yes, pressure swing adsorption, vacuum swing adsorption, and so on. So technologies are coming up. The question remains the same, that how much of the energy penalty this carbon capture itself is putting while capturing the carbon. And many a times this becomes an say, for example, if it is absorption into amine solution. I'm going more technical, but I need to explain it over here. There is a energy required for absorption, and then there is an energy required for desorption. Many times energy required for desorption is very high, and that makes that system not so relevant or energy efficient in that particular. Same thing happens with the CO2 utilization. Sometimes we try to change into the bulk chemicals, but then again finding cycle into the emissions, which not very well welcome. Carbon storage, some mineral carbonization is picking up, like for example, steel industries. Mineral carbonization could be a very good mechanism other than other industries. So, uh, capturing CO2, utilizing it, or sequestering it would reduce the carbon footprint of your product. I'm not going to read this, but you can look at the screen and say that there are large number of technologies which are beyond technology readiness level 6. That means they are demonstrated at in the field in actual conditions. So there are many technologies, and there are technologies which are expected to come in the future. One of the very important technology which in the beginning I started was the biochar, and the biochar preparation and biochar utilization can replace the up to 20% of the coke in the blast furnace. Not all, but the 20% can be done. CO2 emissions can be dropped by 19 to 28%, and sintering process can replace 5 to 15% of CO2. So this, if it happens, other than the other industries like in agricultural, water treatment, pharmaceutical, metallurgy, many industries are around, but then steel industry would probably be getting more benefits of the biochar usage. There are various solutions available. Then comes the thermal power plants, and then there is a connect with the agricultural residue and their conversion into pellets. And these pellets are now becoming one of the very good source of energy for the boilers in thermal power plant, replacing almost 5 to 10% of the coal, which would increase further depending upon the technologies to be adapted. So going to the renewables would help into entire system, and if the power plant starts using the renewables, your overall grid emission factor would go down. And therefore it's not only the renewables such as solar and wind energy which will be important, but also to replace some of the fossil fuels will be as important as the solar and wind. Another thing which I just wanted to emphasize is with the current situations, we are finding that there is a huge requirement of the renewable energy as a biogas, because it gives you concomitant waste to energy. And waste to energy, I'm not here talking about the burning entire waste into the boiler and getting the electricity. That's a low calorific fuel, and therefore the boilers operates at very inefficient rate, and therefore that's not very attractive way. Whereas having the biomass would be biomass getting converted into, or the waste getting converted into biogas, and simply using that biogas is also an could be beneficial, and if it can generate the electricity, that's good. Now, let me just have one slide on the Bharat Carbon platform differentiator. What is the differentiation which we have? Although Dr. Prasad has mentioned very correctly that we need to align with some of the international methodologies, where the certification methodologies particularly, and those need to talk to each other. Compatibility is required. But at the same time, the advantages which we have brought in is the context of the data. For the advanced data processing, which we have had 4 points. One is the context of the data, then the data filtration for QAQC. There are various filtration techniques, very statistical. Some to name a one, just a Kalman filter technique, which actually looks at whether the data is a anomaly or data is just outlier, and that can be found out. We also had included some of the factors like data triangulation for cross validation of the data within the system. One of the way is building it bottom up and checking it top down. That is also one of the data triangulation methods which we have provided. And of course, the uncertainty analysis also accounts for, so that this helps us to make it more and more realistic. As I mentioned before, also multi-value chain carbon accounting ready to realistic accounting. Then providing carbon reduction strategies. This is one important aspect which will come once you know what is your carbon what is your carbon emissions. Next steps comes, what would be the carbon reduction strategies. I also already mentioned about some of the methods of carbon reduction solutions, but the strategies has to be planned differently for every industry in different way. That also depends on the entire ecosystem available around that industry. You cannot add too much of a transportation. You cannot add too much of a emission control, which itself will cost you both on the energy as well as money. Provide scenario creation with solutions to meet the target on the carbon reduction that we can do, and which will help to take the decisions. In a summary, I would just say specific strategies and policies for carbon capture (CBAM) have been initiated globally, as well as, I would say, sensitized in India. Not much initiated, but the sensitized in India. Use of the integrated platform with multi-level approach and the data quality assurance will lead to the improved planning, and several technological options are available for reduction of CO2, for CO2 tag to your product and the processes. There will be different challenges, several challenges, but solutions are equally possible. The last thing which I would like to leave it for you is moving more to the nature. Like we think that the photovoltaic is the very clean energy which we can generate as a solar panel, but the dirty manufacturing of the solar panel is an question. And the clean power is generated at the point of production of the power, but the production of the solar panel itself requires a method which is at the high temperature fusion method. Whereas if the harvesting same solar energy using a very natural way of photosynthesis, converting this biomass into biogas, that would be much more going closer to the nature and reducing the carbon while harvesting the solar energy itself. Of course, the questions needs to be answered, because we are converting it to first to the methane, which if it leaks, it has got a almost 22 to 32 times higher potential as a GHG gas, greenhouse potential gas, as compared to CO2. So, with this, I would like to thank you for giving me this opportunity to put my thoughts over it, for the embedded energy and the solutions available, and how to match it with the carbon reduction strategies. Thank you very much.
Thank you so much, Dr. Rajesh Biniwale, for not only imparting the knowledge on the embedded emissions, but also taking us through the various solutions such as the CCUS, biochar, and biogas. That was really enlightening. Definitely. Moving ahead, I would now hand over to Mr. Tanish Shivani, the founder and CEO of Bharat Carbon. And I will like him to address the issues how Bharat Carbon platform deals with the CBAM and helps companies to comply them. Over to you, Mr. Tanish.
Yeah. Thank you, Shaila, and thank you, Dr. Prasad and Dr. Rajesh, for setting the stage and giving a very holistic view from of CBAM and also on decarbonization technologies that businesses can adopt. Now, coming to the tool aspect, we definitely mentioned that CBAM is a new framework and that as what you call has its own level of complexity. Right now, for any organization based in India, whether it's enterprise or MSME, right, there are compliances in place that they already manage. Now when you look at enterprises, if you look at their sustainability reports as well, they are struggling with scope 3 as well as they figure out how to build that capability internally. Now once we bring out the question of MSMEs, a lot of them haven't started yet or are still struggling to build their internal capability. Now enterprises definitely have the large bandwidth, the large resources, the large capital to build large internal teams to sort of streamline their emissions internally, but MSMEs don't. So where does Bharat Carbon come in? So Bharat Carbon, what we are building is an AI native platform that helps with enterprise grade emissions tracking, ESG reporting, and provides the climate risk intelligence that a business needs to sustain in today's environment. Now there is not just a single framework which is CBAM that is affecting the compliance aspect. There are multiple other frameworks that make part of this entire sustainability compliance as well. Right, with that, about 30% of India's entire emissions inventory is right now covered under compliance. So right now, CBAM being a trade risk is why that is being spoken about a lot more, and that affecting how we do business with international countries is why it makes it more important for even MSMEs to build that capability internally. So what we provided Bharat Carbon is a cost-effective platform tool which is powered by AI, which helps you streamline a lot of these efforts internally. And we also provide advisory with our partners, CBR with Dr. Rajesh Biniwale as well. We provide the relevant advisory to help you ensure that you're not only just meeting the compliance, but you're getting ahead of it. Now going ahead, so the platform that we have built is built for complexity. We cover about 90,000, we have a 90,000 plus emission factor library that is there, and this is continuously expanding. Like the next in what do you call ingestion that we're going to do is going to take the same number up to 1 million and 1.5 million emission factors as well. There are 10 plus frameworks and 10 plus industries that we cover from a knowledge based perspective. So with multiple chemical engineers and Dr. Rajesh Biniwale as well, we have elaborated how each platform sees, how each industry sees this platform. Now, every company has a different layer of how they manage their data internally and the complexity on how they are structured. Right. With that, we have the complete process mapping that comes at an industry level. This entire platform is treated as a foundation where this can be embedded into your organization, not only to build your capability, but also be molded according to your entire company's needs relevant to the industry. Now, for any given framework, you're managing anywhere 1,000 plus data points. Now, when we come to CBAM, when you're managing LCA as well as carbon accounting, there are 1,000 plus data points that you need to manage as an organization. And in a phase wise manner, we help you within a year or two build you that capability on covering the entire scope 1 to 3 aspect. You obviously start with scope 1, scope 2, and then move slowly on to scope 3. But with our platform, that accelerates the timeline on how you build the capability internally. We provide a complete holistic view of about 150 KPIs, so it gives you a complete understanding of your organization, and the workflow that we have internally is about 80% automated as well. So if you see how the platform is architected, we have multiple modules, everything from GHG accounting to reporting to decarbonization strategies, where we do the complete data ingestion, the intelligence, and the governance, and we take you to compliant ready reports on any given framework within 30 to 45 days as well. So that is the speed that you can achieve when you are using a tool in the organization. Now with the how the platform works as well, if you see, there are multiple data sources that you need to collect, whether it's from the customer, accounting, HR, procurement, production, transportation, supply chain, and facilities. We have a complete data ingestion system, the intelligence layer. So we have multiple modes of data collection, everything from AI AI document manager where you upload a physical document, it gets ingested, and it helps you fill the relevant components internally. And as Dr. Biniwale mentioned, our data processing engine is quite strong, where we flag any anomalies, we do data triangulation to ensure that once the final output is generated, it is audit ready. So that is what we enable you to do. And now just giving a comparison between working with a platform provider versus working with a consultant. When you're working with a consultant, you spend 3 years. Every year you follow the same cycle, starting from hiring to collecting data to building the spreadsheet to delivering the report, and then the knowledge leaves, because once they have delivered the report and you have submitted the report, that is where the engagement ends, right? And then the second year, once you restart with them, they will start the same exercise, obviously with the understanding of the previous year, but then they will start the same exercise on what gets updated into the organization. So within 3 years, if you see, all you're getting is deliverables in terms of PDF reports. You're not building a capability internally, so your dependency on the consultant increases as well. Now when you work with like a platform like us, which is providing you both an AI powered tool as well as the relevant advisory needed, we are helping you build a capability. So within 3 years, you go where the first year is in the setup and building the foundation. The second year onwards, it gets faster, cheaper, smarter. So the more you use the platform, the AI gets trained, it provides a relevant benefit to you as well. You require lesser resources, both from our team and your team, to do this. You can have one resource managing the entire sustainability of your organization. And year three is when you start the continuous monitoring. So if you see from year one to year three, the dependency on resources and the knowledge base that you require is sort of reducing, but with the consultant it either stays the same or increases. So that is what we provide at Bharat Carbon. Now, this is again, like from a security perspective, we have multiple data security standards. So your data is completely secured. You can scale this up to 1 lakh plus accounts. So you can add your entire organization. You can also add your entire supply chain, whether your entire supply chain, tier 1, tier 2, tier 3. You can manage global data on this. So if you're a company that is existing on multiple geographies, you can manage with this language localization, with the emission factor data localization. You can manage that entirely on the single platform as well. So that is what we provide at Bharat Carbon. And now I'll hand it over to yeah. So I think, so what I've explained from a product perspective, now Krishna will take you through the entire CBAM process and how our product helps you out with that as well, just to give you clarity on how the entire framework would work and how your compliance journey looks like.
Thank you so much, Tanish. Thank you for enlightening us. Definitely speaking of the use of AI and tech in the Bharat Carbon